Okay, for kicks and giggles, I'm going to use that same set of data from Lecture 3A and Excel and show you how I can use Excel to easily calculate the mean, the deviations, the sum of the deviations, and the sum of the squared deviations. And this will come in handy later when we look at the standard deviation calculations as well. All right, I just copied and pasted the data from our PowerPoint slide, and now I'm going to actually put in some labels for the top of this table. I'm labeling column A X because X represents the individual scores in a set of data. In the second one here, I'm going to label it mean for the average. I could probably figure out how to put an X bar in, but it's really not necessary. And then for the third column, I'm going to call this the X minus the mean, which is the deviations. Okay, let's start with just that. So we're going to test the first characteristic of a mean, and that is that the sum, there's your sigma, of the differences of the values, that's X there, the differences of the mean subtracted from the value, so X minus X bar, you take those, you add them up, it should equal 0. So first thing I'm going to do is I'm going to have Excel calculate the mean for me. And I'm going to do two things. First, I'm going to have it actually calculate it for me, and then I'm going to paste it into this column so that it appears in each cell. So I'm going to just choose a spot down here at the bottom and set it up so that I'm ready to type the mean, and it's nice and labeled. To do that, you can hit equals and then type out the word average. Notice I didn't put any spaces in there or anything. I kind of wish they'd called it mean in Excel, but average is the more common term to the non-stats world. Once you type that in, you can tell you've done the right thing because it's showing up as one of the choices for a function. That's what f of x stands for. F with a little x is pronounced f of x. And that just means that it's some sort of equation that we want it to do. So I want it to calculate the average, and then I'm going to put a parentheses, and I'm going to select the data for which I want the average, end the parentheses, and hit return. And there's that number, 44.5. Actually, I think it started out looking like this, or something like that, when I first did this exercise when I was practicing for you. But what I want to do is I want to make it match what we were doing. So I'm going to go ahead and decrease the number of decimals down to 1. I could have done that, by the way, by going right-click and format cells, and in the number tab for a number, I could have chosen 1 decimal. And it's kind of groovy because notice that it did the rounding for me. It was 44.46. So if you're a little uncertain about rounding, this is one way to check your answers, is because Excel will follow the rules. Now I'm going to take this value, 44.5, and I'm going to copy it, and I'm going to paste it up here into this first mean cell. But I'm going to paste it specially. So if you hit Control V, hit Control Z to undo what you just did. When you right-click or Control-click on a Mac, you have some choices for pasting. You can paste just normally. You can paste the value. You can paste the equation. You can do some weird transpose thing where you take a row and turn it into a column and vice versa. You can paste this, all this other stuff. Honestly, the only ones you'll probably ever use that's special is this paste values. And it's really handy because now, do you see it's got the number behind it? It's still rounded for me in the cell, but in my formula bar, I see that it's the full number. But it's pasted that, and it's no longer the equation associated with it. And that's actually really important because that equation always tries to anticipate what you need. Because what I'm going to do right now is I'm going to collect that first cell, select that first cell, and drag down. And then remember how we fill down? Control D. I know there's another way to do it. Let's look for it real fast just to make sure that a Mac user could find it. Is it a right click? No. Okay, going to bail on that. I will look for it and try and do it in our next tutorial there. But for right now, Control D, which might be Apple or Option D on a Mac, you'll see that it's now placed 44.5 all the way down. If I hadn't done the paste, just the value, then it would have turned into a bunch of gobbledygook, because this one would be looking for cells other places. Don't worry about it. Just do it this way for right now. All right, now the deviation. The deviation is defined as x minus x bar. It's the deviation score. X being the value, x bar being the mean. So to make Excel do this math for me, I'm going to hit equals, click on the first cell, minus the mean, enter, and notice that it did correctly subtract 110 minus 44.5. Last time I checked was 65.5. Now I'm going to select and drag and fill down. You'll notice some of the numbers are positive and some are the negative. That makes sense because I know the mean should be somewhere in the middle of all the values-ish. Therefore, sometimes when you subtract it, it'll give you a positive number. But if it was a smaller number to start with, like the second one here, 25 minus 44.5, is going to give me a negative number. And that's good, though, because this characteristic says that if I take the sum of the deviations, then I should get 0. So I'm going to hit equals, and I'm going to go SUM parentheses, and select my data, close my parentheses, enter, and ding, 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 it's 0. So we have just proven the first characteristic of the mean. The second characteristic of the mean that I want to address is that if I take the sum of the squared deviations, so remember, squared means to take it by itself. So if I had a value, the LU, and it were squared, sometimes that caret's used to show the exponent, like it is here in this picture, the exponent. Squared is the value times itself. So it would be the value times the value. So for example, 2 squared is 2 times 2, which of course is 4. 3 squared, where you want to make sure you don't mess up. 3 squared is not 3 times 2. It's 3 times 3, which of course is 9. Okay? So what I'm going to do to tell this thing to square those deviations is I'm going to go in the next one over, I'll label it, square deviations. The nice thing about the squared deviations is that it's going to turn all these negative numbers positive, because remember from math, negative times a negative is a positive. So to square this, I'm going to go equals, click on the cell, and caret, that's shift 6 by the way, 2. And it gives me a big old number. That's okay, don't freak out. That's why we're glad Excel does this for us. Control, click, and, or sorry, just click and drag, fill down, all right? And I get all these numbers, yuck, yuck, yuck. But remember, the characteristic talked about sigma of the deviation squared. Sigma means sum, so I'm going to go equals sum parentheses and okay. So I know that looks like a big number, but that's because we did all this squaring stuff. The point is that we're supposed to show that this equals the smallest number possible. So to do that, I'm going to dink with our mean, because I can. I'm going to dink with the mean. I'm just going to turn this into 45. And keep your eye on this guy. Maybe I'll paste this next door as a value, just so that you can see how it changes. So I'm going to dink with this mean. Let's just change it to 45 and see what happens. Junk. Fill it down. And that changed all of these numbers because they were relative to our mean, and changed the squared because it was relative to the other one. And you'll notice that our value has changed. And in fact, it's gotten larger. It was 8655. Now it's 8660. So far, our little premise is true. We changed the mean by just a teensy bit. And it ended up making the sum of the squared deviations even larger, where the whole point of a mean is it's supposed to keep it at the minimum. What if I were to go the other direction? All right, our mean was 44.5. Let's go down to just 44. So same game, fill down, makes all the other changes for me, and now it's 8659. So again, it's still larger than 8655. What if I change it a lot? What if I make the mean 25? Just because I can, and Excel's doing the hard stuff for me. 25, all the way down, fill down. Okay, it's giving me these numbers. That's because the number got really super ginormous. So I'm going to make my cell width larger, and look what it's done. It's gone from 8,000 to 14,000. So very clearly has done some bad stuff to my sum of my square deviations. All right, so I believe it. I believe the second characteristic is that the mean, which we calculated, 44.5, truly does give us the minimum amount of sum of squared deviations. All right, so the two characteristics of a mean have been proven true.